Greetings everybody, my name is Patrick once again, and I'm currently in your Genius Path Lab, and I'm a clean energy enthusiast and a solar system engineer. So the idea is simple, just to solar power this lab, which we have successfully did. Why did we do it? It's to help minimize greenhouse gas, to help you people that are working with a whole lot of samples, to have uninterrupted power supply. And we are also supporting the Sustainable Development Goal 7 of clean energy generation. So basically, this is the component for the solar system. This is the charge controller. This is 5 kVA inverter system. This is enclosure box, the DC side where you have the safety devices. This is the AC side where you have the safety devices. This is the changeover. It just regulates the grid and the non-grid. When I say grid, I mean NEPA. In the non-grid, you have solar system for this side. So this is our 12 volts battery system. This is deep cycle, and it is suitable for this lab. We could have also used lithium-ion batteries, but they are very expensive. We saw our connections, well done, and at the back you have the bus bar. So it's 12 pieces, and you have 18 pieces of solar panel up there. We have 300 watts of solar panel, monocrystalline. I said monocrystalline. We chose it for maximum efficiency. It traps sunlight with a greater efficiency as compared to the polycrystalline panel. You understand? So we also have our combiner box out there. It's also a safety device. So after doing the installation, we ensure that our cable routings were properly done. We also gave room for air gap so that in the event of electrical hazard, the airflow will help to reduce any eventuality. And we also have our thunder arrestor up there. You also saw us yesterday digging the axe pit. Why did we do all of that? We did that to ensure that in the event of electrical hazard, that the system is safe. So 12 volts, 12 pieces, 48 volt battery bank. So charge controller controls the charge from the PV, which is off. Alright, so you can see the reading. We have 66 watts. The intensity of the sun is not much. It's about after 9 right now, and it rained yesterday. So this is our 5 kVA inverter system. What does it do? It just converts the direct current from the sun to alternating currents, which this lab uses. Alright, so this is our safety devices. This is 125 amp. It's connected to the AC, right? So that AC we did retrofitting in other facilities, but that AC, we figured out that AC is energy efficient. So I've been test running it and I've been observing it. The system wouldn't trip off. When we did this project in Just, they called us back because the AC is tripping off the system. So what we just did was to replace the AC with a 1.5 horsepower this safety device, which normally trips off when you on the AC, was okay. So from the DC side, you have this miniature circuit breaker. You also have this one for the PV, and you also have this one, surge arrestor. So all these things are extra care we put in place to ensure that in the event of electrical hazard, you are safe. So from the AC side, you have this 125 amp circuit breaker. What does it do? It protects the inverter. This is 32 amp for the AC. This is the 6 amp is connected to the wall socket where you plug your Genius Path machines and the systems. So in the event of electrical hazard, this device will trip off. So during the course of troubleshooting, and you call us, I'll probably ask Fidera please check if this system is off, right? So these are extra care. We go above and beyond to ensure that the system is working fine. So I don't need to take you outside to see the combiner box, but in the event of electrical hazard or issue, that system will also do its work, right? So having solar power this lab, I mean, if you guys are running,
presently the bulbs, everything now, it's
yes. So the focus is the Genius Park lab.
okay.
That's the focus. Like we could have done this and connected all these lighting points to the system, but we wouldn't want a situation whereby it will overweigh the system. We want these samples to run without cutting off the power supply. That is the basic of the design. Alright, so you can have systems like this at home. Like I said, connect your ACs, connect your fridge, your TV, all of that. But the game plan is energy efficiency, right? When you have your NEPA, you understand, you can manage it efficiently. When there is no NEPA, you fall to this. And this serves you, without producing CO2. Like when you are running your diesel generator or your petrol generator, it's noiseless, right? So in this era of sustainable development, in this era of much carbon footprints, when you have systems like this, I mean, you go to sleep, you live healthy, right? So I'm encouraging each and every one of you, regardless of the cost implication, to think about using systems like this. Clean energy, renewable energy. Like I said, we are transitioning from fossil fuel to non-fossil fuel. So put it in your plan and then let us know how we can help you. Alright? So like my teammates already said, no metal should be placed around here to avoid them. This is a time bomb. When carelessly handled, it can explode, but all these safety devices that we put in place will ensure that you people are safe. Right? So I wouldn't want to take much of your time, but if you have any question, please do not hesitate to ask. Do not hesitate to ask.
Sorry, if there is any trip off, maybe the GNS pass trip off or the socket trip off, so we should come to this safety box.
You just reach out. So via troubleshooting, I will know exactly where the issue is from. So I'll tell you what to do. Okay. But we ensured that our cable routing and our terminations are, based on IEEE quality standard. So we do not envisage, issues like that to come up. But when they do, reach out. Okay. We're at your service. Okay. Please, more questions. Fidera, are you not talking?
Well,
ask questions.
Ask questions.
We are supporting women in technology.
And you consider even our own women.
People will support us.
Is there room for training?
Yes, there is.
How much?
You have trainings going on in Lagos. You have trainings going on in Port Harcourt, which when you get certified, you have an edge over your mates. I told you about big data analysis. I told you about energy transitioning. I told you about women in technology. Exactly. So this one is not I studied art. When you come to companies like this, you work with machines. You need to upscale and know what is happening in the industry. I don't have a job. What skill do you have? What can you bring to the table? It's not about writing. You need to be skillful. So that's about it.
What's the name of the company? Or is it
okay, you mean the company that does the training?
The training, the solar installation.
Okay, you have companies like GI. You have GIZ. They are German certified companies that partner with some local companies in Nigeria to give out trainings. Right? So
don't you have your own company?
I have my own company. It's in Port Harcourt. So, but you people that are in Osun State, I could easily recommend companies here close by that you
It can't be done
For training,
online.
right?
Training cannot be done
you
online.
can get trainings on from YouTube, all the other social media. You can get trainings, but I mean, you need to get certified. Having your own certificate is key.
How much is it to learn?
To learn,
How much?
it depends on the package.
From your
If you
company?
want to just get the basic, you could pay as low as 50,000.
As low as 50,000.
Exactly, as low as 50,000. I mean, imagine you having this skill.
As low as
Total,
50.
we have oil and gas company looking for ladies who have this technological know-how. And as interesting as it may sound, you will not be working as an installation engineer climbing on top of the roof. Once you have that basic knowledge, you can work as a project supervisor, you can work as a project manager, you can work in their procurement units. If they talk about inverter, you know inverter. If they talk about this, you know about it. They want to execute project and they say, I need this like 100. You sort it out. Very easy.
There's only the foundational knowledge in engineering.
It's an added advantage, right? But people change career from accounting to engineering. It's just a mindset. Like, I want to learn this thing, and you team up with the right person, you can learn anything. So with your basic skill, you don't need to worry about plenty calculations in in engineering, all right? So nowadays you have robotics, you have artificial intelligence, you have programmers who help you to program all these things and make the work easy. All you need to know is just to have the basic knowledge, and you are good to go.
Thank you, Mr. Patrick.
You're welcome.
We really appreciate you,
You're welcome.
your efforts and your support, and the time that you have spent with the project.
Yes, I like to see ladies who are industrious and who have flair for technology. Yes.
We are grateful. Thank you.
You're welcome. So please reach out anytime, any day. I'm very
The batteries, do they need